As promised, the extras to finish up this world of integument, this first real true organ that we've gotten into. And I've left some of this up from before, but I've added a number of things on the right-hand side. By extras, I want to address a couple of conditions and things like cancer and burns. That's always a good time. But also, I want to include more of the form, the structures. What are some of the things that we see in here? I tried to make sure that this was, hey, epidermis, dermis, hypodermis, and it seems pretty simple. I started to break those into different subcategories or sublayers. But if you look, this is really busy. There's a lot going on in here, and we haven't talked about these things yet, so I'm trying to pull these out to the end. I want to talk about the extras, in a sense, that we find associated with the epidermis, those that we find with the dermis. Really, the hypo, it's primarily vasculature and things like that. Nothing really unique and special down there. So the epidermis, let me check my time. All right. The epidermis, this very distinct structure is hair. And I think I can say pretty much we're all hairy. And we produce these long shafts of keratin. It's a hard keratin, more so than the soft keratin that we find in the superficial layers of the epidermis. Nails, let me just jump off for a minute. Your fingernails, same thing, it's a hard form of keratin. So the nail and the epidermis that you have just adjacent to it, they're all keratin. It's just a slightly different form. Now hair has a number of functions. You'll be seeing that my hair will be getting longer and longer, considering I'm not allowed to go and get my hair cut, and I'm not going to cut it on my own. You'll know when I start wearing a baseball hat that I might have tried to cut my own hair. Now hair, when it comes to body hair, when it comes to, I'll use an example, my hairy arms. There are a couple of different functions of hair, and probably one of the, in my opinion, most important is temperature regulation. So we regulate temp by whether or not the hair is standing up or whether the hair is laying down. Which I guess brings me to this, and I can't avoid it. That little tiny muscle. Now, some of you might be thinking, wait a minute, he's got that under epidermis, and look down here, it's in the adipose tissue, all the way down here. Shouldn't that be hypodermis instead of epidermis? And the answer is no, it should be epidermis, because take a look at that dermal papillae. It's all the way down here, and all the way back up. Cut it out there, we've got this nice little gland that we'll talk about. So, the hair is an extension. It's still surrounded by the epidermis, even though it's buried nice and deep. Remember, epidermis can be deep, it can be shallow, or in the case of surrounding a hair follicle, it can be really deep. So temperature regulation, if we're cold, what we have to do is we have to be able to raise that hair up just a little bit, kind of like these are. And it helps to trap heat next to our body instead of letting it wick away. This muscle, this very distinct muscle that's in here, it's not labeled on this image. It's called an erector pili muscle. The erector pili muscle, when it contracts, pulls the hair up. When it relaxes it, lays it back down. So these are all modifications to the epidermal layer. Now, something that I think is kind of cool about these erector pili muscles is that it gives us a little bit of an insight to our evolutionary past. Maybe you have a dog, maybe you have a cat, and you scare it, or it gets real aggressive and it wants to look big. Hair on the back of the neck goes up. My dogs will get this scruff along the back if they feel threatened. Well, that's what other animals do. Well, it's what we do as well. In an earlier video, I mentioned that, I alluded to goosebumps. That's what we have when our hair stands up because we're cold. We have a little bump that pops up at the base of each one of the hairs. But also, when you are scared and you want to look big, and I want to look big, our evolutionary past still calls on me to have my hair stand up. Not on my head, but for example, on the back of my neck. So as I said, if you're watching a scary movie, or maybe you think there's an intruder in another room, all of a sudden the hair on your arm stands up, the back of your neck stands up. It does it because you want to look big. It's a beautiful example of our evolutionary past. That's done by the erector pili. Then once you've warmed up or you're not scared, it will relax, the hair shaft will pivot down, and it will lay closer to the skin. Now I'm going to try and cut through all the noise of these two types of glands. When we talked about glands briefly, I told you that there's a lot of different ways to define what a gland is, and different books will give it different names. Here's what I want to do. I want to look first at what are called eccrine glands, E-C-C-R-I-N-E. These are also known typically as sweat glands. This is an eccrine gland. It's this big convoluted tube, and it's all epithelial. And that tube, if you follow it, so we've got a lot of secretion that happens down here, and it works its way all the way around and exits through a pore. And this is primarily water. Some of those wastes that I mentioned before, salts, ureas, things like that, those will come out with the eccrine as well, not equine. I also mentioned, as a little piece of trivia, all of us sweat about 5 liters per day. That's totally unnoticeable. So if you think, well, why do I have to keep drinking water? Why do they say, oh, drink this much water a day? I'm not urinating that much. Where's the water going? I should be bloating up with water. No, we're all secreting sweat onto the surfaces of our body, but it goes so slow that we wick it away, we don't even notice it. Now, if you start exercising, working out, running, then you're going to put over 5 liters a day out, and all of a sudden you realize, wow, man, I'm soaked with sweat. So eccrine glands, they're these very unique looking structures down here. Then there are apocrine, or what are also known as sebaceous glands. And instead of emptying onto a pore right on the surface out here, it's going to secrete into a hair shaft. It's going to secrete into a follicle. Now, a big difference here is that eccrine is primarily water. But when we get to apocrine or sebaceous, and they'll secrete what's called sebum, S-E-B-U-M. Sebum is fatty acids and it's lipid and oil based. So if I was to ask, hey, what would be the function? Why would you want to put oil into a hair shaft? You can probably figure it out. Your hair is growing down here and it's pushing out. As it pushes out of the follicle, it needs to be lubricated. So that's why we see an oil gland or a sebaceous gland or a type of an apocrine gland associated directly with the hair follicle. There are a couple of other things, though, that these are involved with. One is the very exciting thing once you had gone through puberty of body odor. When you are prepubescent, you can sweat like crazy, but you don't have that BO smell. There's probably got to be a better scientific term for that, but you know what I'm talking about. That doesn't happen until these sebaceous glands begin to really mature, and what they secrete kind of changes in their composition. Also, pheromones. Pheromones are chemicals that are given off. Insects use pheromones. All sorts of different animals will use pheromones. We don't use them that much because our sense of smell is really bad. We'll get around to that with special senses in the nervous system. But we do produce them. We kick them out. We don't really have any good idea of what they're for. There have been some interesting studies that go with things like sexual attraction, but we don't produce much pheromone at all. They would be coming out of these apocrines. Now I've got two other little bullet points under apocrine. Ceruminous and mammary. Ceruminous, let me get the word right. Ceruminous are these modified apocrine glands that we find in the ear, and they secrete a wax. So probably at some point in time, you have cleaned wax out of your ears. That is cerumen. Not to be mistaken with sebum, which we find coming out of the follicles with hair. And then, if you're female or if you're male and you really want to do an interesting course of hormones, during pregnancy, you will mature your mammary glands that develop down to mammary ridges, and you'll produce milk, which is another one of the many amazing things that females do to take care of the next generation of a pregnancy, of a child, of a baby. So these are all glands, they're all epidermal in origin. So yeah, there is a whole lot going on in this most superficial region. If I jump down to the dermis, now we're not talking about glands so much, we're talking about sensation. Remember, we're able to sense our world. We're able to pick things up about our world based on skin, one of those big functions. The dermis has two different types of nerve endings. We can generalize this. The first is what's called a Meissner's, hopefully this is still in our view, corpuscle is a great term. And with this diagram that I'm using, a Meissner's corpuscle would be this thing. It's not labeled. We have nerve endings going up to it, and the nerve ending as it comes in here is then wrapped by other tissues. And this is what we call a Meissner's corpuscle. A Meissner's corpuscle allows us to detect very, very light touch. If you've ever had somebody that might be right behind you, that maybe you're picking up the very light breath of somebody across the back of your neck, like, I sense that. What's going on is your Meissner's corpuscles are picking that up. Also, I think about here, I covered that up. Looks like there's some free nerve endings, some more free nerve endings. These aren't wrapped by tissue, they're just an ending of a nerve. And in the dermis, what we find out, and this is going to be in the papillary layer, I guess I should have mentioned, up towards the top, the free nerve endings there are all about pain. So if these are fired off, these little free unwrapped nerve endings, that's when we detect that something's wrong and we feel pain. If we go down into the reticular layer, go deep to that, we've got another type of a corpuscle. And let me see if I can find one of those corpuscles down there. It's not really showing on this diagram, but you would have the same thing. Let's say here's a nerve. We would have it surrounded by a corpuscle as well, but it's called a Pacinian corpuscle. The Pacinian corpuscle also detects touch, but it's deep touch. So if I squeeze my forearm right now, it's my Pacinians that are picking it up in the reticular layer. If I just brush lightly across the top of my skin, it's the Meissner's. So we have different neurons, different nerve endings that are able to pick up different pressures on our bodies. Also, we have free down there as well, which I don't see very clearly on this image either. The free essentially look just like the ones that we find in the papillary layer. Difference is the free in the papillary, we detect and sense pain. The free in the reticular layer, we detect and sense temperature, hot and cold. I believe our textbook only talks about hot, but we pick up hot as well as we pick up cold in the deep layers, the reticular layers of the dermis. That gets us to the hypodermis. Nothing much new down there in the hypodermis. So nothing to add on as far as extra. So hopefully when you look at this and look at the ones in our text and other ones online, you're able to go, oh, I know what this is. And yeah, I know what that weird looking thing is. And hair and what kind of substance is going to lubricate the hair coming out of the follicle. The layers, where would I find a spinosum? Where would I find the dermis? It's pretty straightforward. So hopefully what I've done is I've allowed you to take, once again, you can't see it over here, the form of all of this and relate that back into the function. And this is something that's personal. It's yours. You can see it. It's not something that you need a microscope now to be able to pick up on. Now, a couple of last things before I wrap this up. See how much time we've got, and we'll call it a day with Integument. And I'll get these uploaded as quickly as I can. I mentioned in an earlier video, I think it might have been the introductory video, and the exam for this is not going to be on Monday. It will be down the line. Check your schedule. I think it's 2 Mondays after that. I'm going to be doing things like asking you about burns, 1st degree, 2nd degree, 3rd degree, and some of those questions about burns you can only answer if you understand what's going on in the different layers. So become familiar with 1st, 2nd, and 3rd degree burns, heat burns, and don't just go, okay, well, I looked it up on Google, a 1st degree burn is this, 2nd is this, 3rd degree is this. How does it apply to these different layers, and how may it impact the function? Because that's what I'm going to be asking you. More on this over the next few videos as we move into, I believe bone is scheduled up next. Also, I think it's important to mention skin cancer. The most common cancer, we hear about breast cancer, we hear about pancreatic cancer, we hear about all sorts of different cancers, but we don't think that much about skin cancers. Where do you think you would find basal cell carcinoma? What layer? Where do you think you would find a squamous cell carcinoma? Think about the layers. A malignant melanoma. Tie in melanoma with the different cell types that we've talked about, and you should be able to determine right where a melanoma comes from. Melanomas are deadly. There's at least 132,000 diagnosed cases of deadly malignant melanoma per year, which is why you need to minimize exposure to UV. And if you have to be exposed to UV, really up your SPF. I think about 50 is the maximum. If you go above 50, you're just wasting your money. But one of the things that I think is so important about this, we hear about all of these other cancers, but malignant melanoma is the #1 cancer, last time I checked, in females between the ages of 20 and 29. And seeing as most of you are either there or moving into that segment of the population, this should speak to you. This is something that you have to deal with. This is something that will be impacting you, may impact you and your friends and colleagues. So when we look at the form, we look at the function, we look at the extras, and then we can tie in some pathology with this. Hopefully, by the time this video is over in about 1.5 minutes, you are looking at skin a little bit differently, I hope. Also, I'll leave you with this. Is it possible to take a pin or a needle and poke it through your finger and not have it bleed? I contend it is. So my question to you is, how is that possible? And you can't answer that question until you know the information about the different layers. So with that being said, I'm going to shut this off. There's my allotted time, and I will have the next video up hopefully soon. Any questions on any of this material, cell division / cell cycle information, histology that'll be on the exam, all three of those will be this down the line. So you get a little bit more time to digest. So hopefully everything is starting to get put together now. All right, take care. Email me if you have questions.